Welcome to another week of In Rhythm Lightning Talks. Woo! My name is Jen Crawford, for those of you who do not know me. And In Rhythm's Lightning Talks, they happen on a weekly basis, 5:15 p.m. Eastern. They are a place where our practice area consultants get together to teach back to the In Rhythm community and everyone at large. For those who are joining us on LinkedIn Live, welcome. Thank you so much for joining. This week, I have the pleasure of co-hosting the space with our iOS practice consultant, Rafael Aguilera. Could or could not be related to Christina, we don't know yet. And he's going to be talking about Snapkit Framework for building user interfaces. We're gonna start off the party with a poll. After the poll, Rafael will take over, and then we will leave room for question and answer at the end. So, as I mentioned, to get the party started, we are going to start with a poll. So, 2 questions for you today, nothing too daunting. First one, have you ever built an iOS application? Secondly, which of the following have you used to build the UI for an iOS application? Oh, we got 1 yes. Well, Rafael, we have a lot to learn today. So after this, we're all going to be building iOS applications, right?
Well, some make it easier, that's for sure.
So majority of people here have never built one. So lots to learn, lots of exciting things to be taught and learned today. And then I'm guessing, Rafael, this is you. So you used all of them.
Yeah. Yes. I've used all of them.
Okay, so you use lots of different components and frameworks. So you will tell us if Snapkit is the best one, the worst one, or in the middle. So with that being said, I'm going to hand it over to Rafael and get the party started.
Great, thanks. All right, so today I'm going to be showing you a bit of Snapkit. And so let's get started. So what is Snapkit? Let's start there. Snapkit is, well, primarily first, it's a framework. It's also a domain-specific language, which means it's a way of writing something in a specific way that pertains only to a specific platform. So what it does is it facilitates auto layout on iOS and OS X. It's like simple, expressive. You can chain stuff together, and it helps you build constraints, ensuring in a way where it's like very, very easy to read. If you've ever worked with other iOS constraint building tools, they're typically very, very, very ugly, and we'll get to that and I'll show you. It's type safe by design, so it reduces programmer error and it keeps valid constraints, makes sure that what you're doing is correct, and it tells you if you're not. So it's installable through CocoaPods and Carthage, which are package managers in the iOS realm. You can also install it manually. And best of all, it's free to use in all projects under the MIT license. So that's always a plus. So what are some of the advantages of Snapkit? Because you're building code-based views and layouts, you get to avoid interface builder, which is honestly just, it bogs down. It's really slow. It's like a visual builder that Apple came out with towards the beginning of iOS. And it's what they've been kind of using up until somewhat recently. And we'll go into that a little bit. The readability of like constraints becomes a lot easier when you're using Snapkit. We'll also go into that and I'll show you some examples. Source control change logs are usable again, rather than having a bunch of nonsensical XML. So the way that interface builder works is it basically gives you a giant XML that kind of describes what your view looks like, which tends to be really, really, really ugly. It's not really readable for humans. It's mostly meant to just for the computer to read it and to display what it is. And then there's no need for confusing notations such as visual format language, which I'll show you what that looks like. And you guys can tell me if that looks confusing or not. And then NS layout constraint class as well. It wraps around it. So it still uses that, but it does it in a way where you'll see that it's much cleaner, much more concise, and just better in general. And the best part is you can chain the constraints for a single view in one expression. So let's dive right into this. So I'm going to give you a few examples of what each of these looks like. So this is what NS layout constraint classes look like. For each time that you want to create a constraint, you have to make one of these, and you have to tell it what item you're constraining, what attribute of it you're constraining, the relation of it to where you're constraining it, the attribute for where you're constraining it to, and multiplier, and then you have to activate it. And you have to do this for every single one, and it can be pretty daunting. So one solution that Apple came up with, which I honestly kind of hate, is visual format language, which kind of, you grab the view that you want, you give it a format string, and then you plug that into NS layout constraints. A little bit better, but it's really limited, and it's also still really ugly. Just think about building a whole user interface using something like this. It's kind of awful. And now this is what Snapkit does, and this does the exact same thing that the other two do. In fact, it does more than what the middle one does, because the middle one only constrained it to the right and to the left. So this, and I'll break this down and I'll show you what's actually going on here, and what each thing is doing. So basic usage of Snapkit. So a view's got to be added to the view hierarchy before constraints are made. That's true for, I think, every single solution I've shown you so far. So nothing new there. Syntax and structure. So let's go over this. So this is just your view. Then this is a library that you're accessing inside of it. And this has a bunch of different functions that you can do. And then within here is a completion block, and you just tell it using the make right here that you create what aspects you want to access and what you want to do with them. So there's keywords such as like edges, and I'll go through all those as well. You can like add insets and offsets and all sorts of really cool stuff. Yeah, so I'll break these down a little bit more. So here's an example. You create a view, you add it to a super view of some sort, then you make constraints. This does the same thing. So this is like, you can do it while you constrain to the top, to the left, to the bottom, to the right of whatever the super view is. There's different ways, different things you can constrain it to, etc. This is a pretty good example. This is, you'll see this a lot in a lot of these like Snapkit based iOS projects. It also allows you to chain together constraints, which is really cool. So you can do stuff like when you add after you add your view and all that, if you don't want it to be as verbose, you can, if it's like for example, back here, it shared these two. If you look, most of the code is repeated. So shares most of the stuff. So why not just, make top left equal to the super view and then offset it by 20, and then same thing with the bottom right. So you can see how this like makes it a little bit less lengthy, a little bit more like understandable. And then it gets even better. You can actually use primitive types, and I'll go further into that, but here's an example of a primitive type, which is UI Edge Inset, being used to make all of those insets, to add all those insets where you would normally have them before. So this like -20 and +20 here is basically the same thing as right here. It's just using a primitive type what you would normally have used before. So there's different ways, and this is the same for NS layout constraint. There's different ways to relate the constraint that you're creating. And so I'll go through these. So you can either make it equal to a target. They give you this nicety where you can make it equal to a super view directly without having to specify that super view. So if you have like a really long name for the previous view that you added it to, this is always super nice to use. You can make it less than or equal to, and I'll go into how that relates to other stuff. And then same thing with the other ones, and then greater than or equal to. So this is the same right here. This equal to, for example, is the exact same thing as this ns layout constraint dot relation dot equal that you would have used in the other part of the of that class. So here's all the attributes you can go through. There's quite a bit of them, so I probably won't go through all of them, but left, right, top, bottom, leading, trailing, width, height, center X, center Y, and last baseline. So these are exactly what you'd expect. Leading and trailing tend to be used for stuff with text in it, or things where it matters if it's left to right, right to left, stuff like that. Width and height is pretty self-explanatory, et cetera, et cetera, et cetera. So this is where it gets very cool with auto layout. The reason Apple made auto layout was because they started making different size screens, and they were like, oh, how are we going to solve the problem of how do our UI scale on different screens? And what they went with is relational, is how does this fit when in relation to other parts of your screen? So auto layout allows width and height to be set to constant values. If you want to set a view to have a minimum maximum width, you can pass a primitive to the quality blocks. So what this means is basically you can cover several screen sizes by making your views change in size depending on the amount of space available. So if I want my view to expand between 200 to 400 points, you can make the width greater than or equal to 200 and then make the width less than or equal to 400. So that means that my width will literally the size of the button will literally change based on what it is able to use and what it needs to use and the constraints that you set up for it, which gives you a lot of flexibility. It makes it so that you can build one UI code for all your views. You don't have to worry about having all these, it makes it work so that your app even works on an iPad from an iPhone without having to make any changes if you really, if you take the time to really work this out. So Snapkit works with primitive types, which is awesome. Primitives instructs can be used to construct your relational constraints. Some really good examples, which you've already seen a few, are CG size, UI edge insets, ints, and floats. So for example, I'll give you some examples here. You can make the top equal to a 10, which is using an int to constrain the top to the super view to whatever view it's a sub view of, and then it adds padding of 10 points to it. You can go as far as 0.5 if you use a float. So same concept. You can change the size to be an exact size if you want using CG size. So this is also the same thing as a struct. Technically, it's like a built-in type. It's a primitive type, so it's allows you to make something a specific size. And then this one, which you guys already saw, is UI edge insets. So this just constrains everything to the super view, and then it gives it a padding at the top of 10 and the bottom of 10 and left and right 0. So you can use primitive types, which is crazy and awesome. It makes it so much easier because then it just kind of means that converting code is a lot easier. So yeah, so priorities. Priorities basically allow your code to be flexible so that the system knows what constraints it needs to break and which ones are more important than others based on what you tell it. So say for certain screens, it makes more sense for it to break left and right and just kind of constrain it to fully on the left and fully on the right. And for other systems, it makes more sense to just keep it, centered or something like that. So you can specify exactly what you need. So when you have conflicting constraints, it knows what it makes sense to break and what it makes sense not to break. So you can always get the best looking UI that you want. It has a built-in function called dot priority. In this, you can enter a value from, I believe it's 0 to 1000. And then it has some nice little shortcuts like dot low, which sets a priority to 250, medium to 500, high to 750, and 1000 to required, which, it's pretty nifty. So references. So this is actually super important because this is one of the things where the NS layout constraints is pretty obvious about like how it's doing it. And then people are like, oh, but like, how would I go back and like update a constraint or something if it's like inside of a closure? So what you do is you first create where you're going to save the reference to that constraint outside of your block. So you create a reference to it. And then at the end, you just tack on a dot constraint and it'll save the reference right into there, and it'll still make the constraint, and you'll have an actual active reference. So if you wanted to deactivate it later down the line, you can deactivate it by literally simply calling deactivate on it. If you need to update a reference to or update a constraint, you can update the offset of it. If you need to do anything to it, you can do whatever you need to. You can even remove it, whatever you want to do. So it's like super powerful. So updating constraints, there's the way that I just showed you. So you can either update the offset or something like that, or if you want to change constraints completely, you, instead of doing, each and every single one by one, you can simply use update constraints instead. So if you have a button that has a width of 100 and you want to change it to 200, you simply call this and you change it to 200. That's it. Simple as that. One thing to note though is that you have to update all the constraints. So this is one thing that kind of is not so good about Snapkit, is you have to update every single constraint. It can't intelligently know. So like you're basically, it's almost like remaking them, but without remaking them, because if it sees that it's the same, it'll keep it the same, but it has to have it. Otherwise it's going to complain and it'll throw out an error, which, problems. So yeah. You can also remake constraints fully. Sometimes it's simpler just to remake our constraints rather than updating every constraint within our view. And in order to do this, you use remake constraints, which you can see right here. And I'll show you some other cool examples. So this basically does the exact same thing as the original make constraint, except it takes off every constraint from the view that's calling it before it makes the constraints. So a lot of times, if depending on memory constraints and other things, it just makes sense to just use remake constraints, because if it's like super lightweight and it doesn't really matter if it does a little bit more processing, then sometimes it just makes sense to use this. So with the addition of safe area layout guide, you can also constrain to it as well using Snapkit, which is really cool with all these like weird wonky looking devices that we have now, with like what do they call it? The nub at the top and the swiper at the bottom and all that. So they added that in iOS 11, and people were like, oh, well, how am I gonna know what to constrain to for like a table view or something? And so they added support for you to be able to constrain to those. So you can now grab say you have your class, you add a table view, and then within here, you add your table view and then you make your constraints. So instead of constraining it to the very top where it's gonna scroll through, your status bar and like all that stuff, you can constrain it to the views safe area layout guide and then constrain it to the top. So that's pretty useful, pretty cool. Somewhat new addition. It was from like 2018 or 2017, I believe. So debugging. This is a big one because I've worked with some projects that have a lot of constraints, and it can get really tricky to know what's causing what to look in certain ways, and this helps quite a bit. So the dot label function allows you to give like your pescare constraints names so that you can see them more easily on debug logs, and you can kind of pinpoint issues and know what's going on. And here's a really good example. So say you have a button and you make a constraint to some other view to the top of it, and you label it my button's top constraint, right? using the dot labeled. If for some reason some other constraint takes higher priority and it needs to break it or something along those lines, this is the kind of error you would normally see, or you would see is this. And then this would be gibberish in here. So this is the actual label that you gave it, which is good, as opposed to getting some, you know, crazy point in memory that means nothing to you. So and it tells you where, and it tells you, like, it gives you all the data that you need in order to be able to fix this, which makes it super easy to like identify what constraint is giving you problems. And especially if you're very meticulous about using all these labels, it definitely helps quite a bit. So for animations, I thought I would just give you guys a cool little demo. Since animations are like a really big part of building UIs, Snapkit actually does a really cool thing where it makes it super easy to animate views. So you can basically change whatever constraint you want for wherever you want it to be, and then just make a call using UIView.animate, the function, and you get perfectly good animations. You get super fast, fluid animations, and I'll show you that right now. Actually, let's just hop right into that. So I have this nifty thing where I can just pull this up. So as you saw before, here's like your regular UI view box. Here's just another button I added in, an animate button. The box is a black box. All I did here was just add a target for the animate button so that it knows what function to call. Made the button blue. I added both of my views, and then I installed constraints. And that's all that this is doing until you hit the button, and I'll show you what this looks like. So let's run this real quick. So here you have the box, little black box, and the animate button. So what I do here is I'm remaking the constraints of the box. So what I'm doing is, before it was just in the center of the screen and the height and the width were equal to 50. So what I end up doing is I put it in the top of the screen, and I keep the same exact like center. The center X is still equal to the super views. So the only thing that'll change is its Y position. And then the animate button, all I did was I just changed the width to 300 from 120, and that's it. And then here's another perfect example of safe area layout guides. And I'll show you what both of these look like. Especially this one. This one's a perfect example of why you probably want to use this kind of stuff, especially with these newer phones. So all you need to do afterwards is you call the layout if needed, and it'll animate it out, and it'll even use all the options that you give it, like curve ease in now, or whatever other options you want to use. And you can set a delay or your completion handler afterwards if you want to do some other animations or whatever you need. So let's just run this. So you get the button getting wider, and this goes straight to up the very top of the safe area. So you get nice smooth animations, everything working perfectly. So now let me show you what would happen. Cool. So you can see like how you would build like very complex UIs and complex like animations using something as simple as this, like really, really easy to read. Like, so I can show you, like, say I made this like 300 and then we didn't do the safe area layout. We just constrained it to the top. I'll show you what this kind of looks like and why you really want these safe area layouts, especially with the newer phones. Okay, so see how it just covers the very top of the screen, and it's just kind of ugly and bad, but the animation still took into account the like it getting bigger as it's going up and all that for it from when I changed to 300. So it's pretty cool stuff. It's really powerful stuff. It's if you saw what making animations looks like most of the time, this is a lot better, a lot nicer. So let's go back to the slides. All right. So just like every great tool, there are downsides to the Snapkit, and you guys might have seen one already. I don't know if, how many devs out there were like, wait, you have to build it every single time in order to run it, in order to see what changes you are making. And yeah, that's actually a very big flaw, or was a very big flaw. That's, I think, in development for or a lot of platforms. But beyond that, I would say it's still just another framework, another library that you have to add on, something else that you have to upkeep. It's not a native solution, so that's kind of a problem, you know. So like if one update happens to Snapkit and it just breaks your app, you have to still go through all of that pain. Another, and probably the most obvious one, if you're familiar with the iOS realm, it's the introduction of Swift UI. Swift UI is a really great tool for building UIs that Apple actually rebuilt and re-architected everything from the ground up for. Before, all of your views and stuff were made using UIKit, and they've completely, you know, they're phasing that out now slowly, but they're still phasing it out. So Swift UI is built on top of UIKit. So it's kind of one of those things where Snapkit is probably either they're going to adapt and, you know, adopt the newer Swift UI stuff so you can still use it, or it's just going to go away. So that's kind of a bigger thing, you know, but Swift UI is great. It's really powerful tool. And the reason they made it is to tackle all the problems that Snapkit was tackling as well. So it's kind of cool at the same time. But yeah, so the other part is what I told you. You have to run it every single time to see your visual changes. And some of these projects where it can take up to like 15-20 minutes for you to be able to get a build, that's nightmare scenario, but that's just a reality you have to live with, because interface builder 99% of the times ends up breaking as well, does the same thing. Everything and anything that has a visual builder, even unfortunately the Swift UI ones, tend to break now still. So that's just a reality when you're programming in iOS, and that's why it's really important to get your app speeds up pretty good for compilation times. So in conclusion, Snapkit is an awesome tool for building UIs. It takes care of a lot of the stuff that you need to do. It does a lot of the work for you, and it makes it really easy, especially to do those animations. It's actually really fun to do those animations. So yeah, here's some useful links. And if anyone has any questions, just let me know.